Good morning, everyone. I hope you had a lovely first day, and looks like a bunch of you managed to come here for the first session, so that's good. That's promising. Anyway, so today we'll be talking about some pipeline patterns, CI/CD pipeline patterns, especially in the light of the platform engineering, platform team movement that's been growing strong these past couple of years. But before we kind of get into the nitty-gritty of the topic, let's start with a little story. It's a war story, not a horror story. It has a nice conclusion. But anyway, about 10 years ago, I was working for this large British retailer. I was on the Android team, working on the kind of main retail app. We also had our peers in the iOS team, basically both building the same app for two different platforms. And we had things figured out, as one can have in software anyway. So we were following test-driven development pretty much every step of the way. No feature development would begin until we had full functional requirements agreed on and signed off by product manager. We had a really nice kind of collaborative environment going. Everything was essentially 100% tested, unit tested, functional tested, everything. So what could ever go wrong, right? Because obviously we worked in this big retail environment. The organization had to be ready for risk. So one of the features we were building was essentially a drop lock. So we wanted to be able to lock the applications, which, as you might know, are installed on users' devices. They're not web applications, so you can't just flick a switch and a different website shows. You actually have to ship that code to the users through stores, etc. But we still wanted to be able to essentially remotely disable the apps in case a global shopping system outage or whatever. So we decided to have this central configuration mechanism, which we use for a bunch of other things anyway, that we could use for drop locking our applications. And iOS team and our Android team essentially agreed, okay, that's how we want to do it. We use this existing config, easy peasy, right? Go out, test this, build this, ship it. Everyone's happy, everything's passing on CI, the users got this new feature, and nothing could ever surprise us, right? Fast forward 3 months-ish, and we did have a global shopping system outage. Nothing worked. And obviously, I got a call, I was on call for Android. Hey, can you drop log this? Here's the message that you want to show. My iOS peer had the same call, and obviously we jumped on a call, said, okay, so we follow this checklist, which we already had prepared 3 months in advance. Drop lock Android, drop lock iOS, and test it, essentially run it once to see if it works, and both apps started crashing. And we didn't figure out what was wrong then and there, but we essentially rolled back to a full. We had a fallback mechanism essentially, which allowed us to drop log the apps without that kind of mechanism that we built. But yeah, that was about the only post-mortem that I was ever part of, where we basically discussed why we couldn't break something. Anyway, it turns out that the reason why things broke was the config that we used was slightly different for iOS and Android, and we were both relying on it. And once only a single application was kind of disabled, it all worked fine. But when both of them were disabled at the same time, then obviously both of them broke. iOS broke Android, Android broke iOS. Bizarre. Anyway, the processes that we ended up putting up afterwards were essentially have all of the common functionality, so like this common configuration, extracted and owned by a separate kind of sub-team. Let's call it a platform team, with both Android and iOS as main clients, consumers. So anything that touched both platforms was owned by this team, obviously made of our existing engineers anyway. We didn't have a new bunch of people coming in. But everything had to be tested on both platforms at the same time. Everything was owned as a product together. And obviously, we didn't have these outages going forward. Essentially, what this story tells us is that with any increase of complexity, you increase the risk of something breaking up in a spectacular fashion, I suppose. I like this analogy of the blade of Damocles. So this is an old story. There was this ancient king who had everything, and his servant Damocles was very envious of that king. He was like, the dude sitting on this gold chair, everything is brought to him. He has everything, right? So one day he says to the king, hey man, can I swap with you for a day? I'd like to see how this feels. And the king was like, sure, all right. Sit here in this gold chair. So Damocles sits there on the throne, and then he noticed that the king had put this massive sword on a very thin thread just above his head. And he was like, what's this all about? It was like, this is to remind you that despite you have everything you could possibly imagine and want in this world, you're still constantly need to be on your guard, because to paraphrase Spider-Man, with great power comes great responsibility and also great risk. And that's really, really similar to how we are building things and when we're responsible for software systems. Because with great value, great business value, naturally comes great complexity. Like, if you want to increase building business value of a piece of software, you probably need to add some code. If you add some code, you increase that complexity. It might not be a linear increase. I hope it's not an exponential increase in complexity, but it is an increasing complexity. Increasing complexity increases risk, and that blade just keeps growing and the thread just keeps getting thinner. But luckily, we have, as an industry, as a field, we have developed ways to mitigate this risk, to minimize the chance of something happening, and also to allow us to recover from any disastrous scenarios of like a global outage or whatever. And today's session is going to be discussing one small sliver of that in the light of pipeline and CI/CD pipeline patterns that you can adopt. My name is Markan. I'm a developer advocate at CircleCI. Been there for 3 and a bit years. And I've talked to a bunch of teams using CircleCI, using other CI/CD tools. I love talking about that stuff. What their challenges are, how they're solving it, organizational, technical, any type of challenges. I want to understand them. I want to make sure that I can address them as someone who they call an expert. And this talk is essentially a collection of these patterns that I noticed and discovered and discussed. Anyway, if you're not familiar with CircleCI, is anyone using CircleCI at the moment at all, or not really? Good. Okay, so we're a CI/CD platform. Anything from small single-person projects to large Fortune 500 enterprises, open source, closed source, whatever. We can probably build it on CircleCI. Anyway, let's talk about patterns. Besides swords and pipelines, I also like planes, so there'll be some airplane references in here. And if you think about a plane from a pattern perspective, you can probably imagine a tubular body, 2 wings, a tail, some cockpit in the front, And that's a plane. Everyone has the same rough picture in their mind because humans are pretty good at recognizing these patterns. So I asked my friend about a definition, and this is what it said. Patterns are basically everywhere, and humans are actually pretty good at spotting them. We developed evolutionarily to spot these patterns where they are. You can look at the clouds, you see, okay, this one looks like a plane. This one is a plane, maybe. This one is a cow, whatever. You know what I mean. And essentially in software, it's no different. Like a pattern allows us to apply some prior knowledge. For example, you're familiar with gang of 4 patterns, singletons, etc. You're familiar with our MVC, MVVM, like model view, whatever. You're familiar with, I don't know, event-driven architecture. They're all patterns that you can apply to different systems. And if you hear about this, so, okay, something is event-driven, oh, we might be using a Kafka here somewhere. You immediately know what to expect when you're talking about this. Actually, the interesting bits in here are what I highlighted. So regular and recurring arrangements of some motifs, and characterized by their repeatability, predictability, and systematicity. And they can serve as a basis for creating new designs, solving problems, identifying relationship, blah, blah, blah. And that's here, it's quite important because they serve as a basis to apply in new situations. One more last plane example. If you ask a 5-year-old to draw a plane, they're gonna draw what I described earlier, right? So tubular body, 2 wings, tail, etc. And you take that picture, you show it to anyone in this room, they will know immediately it's a plane. That's what I'm talking about. Same as if you ask a 5-year-old to draw a car, show it to anyone in this room, you'll immediately know that's a Cybertruck. So now we talked about patterns a little bit. Now let's talk about platform engineering and platform approach. With this, it's essentially all about finding these commonalities in our teams, in our software day-to-day work, and applying them in some kind of systematic way. So you think infrastructure. So you can have an organization that uses 2, 3 cloud providers, or you can have an organization that uses a single cloud provider. I can probably assure you that the one that uses a single cloud provider can spin up new projects faster and more resiliently than the one that uses multiple. Obviously, there's caveats everywhere, but you usually also decide on a VCS provider, GitHub, GitLab, whatever it is. And you stick to that. You stick with a programming language. You select Java. You decide on which versions you're going to use, where you're going to allow, or you select Python, whatever. That's all kind of this platform approach. Common tools that you can then apply everywhere. And if you're starting a new project, your teams don't really have to have this cognitive extra cognitive load of thinking about what else they need to pick, because most of the common defaults are already picked for them. Same goes with CI/CD tool, right? So you select Circle CI, GitHub Actions, whatever it is, and the more often you can do something like that, that you unify your tooling, the more benefit you can get from it by concentrating expertise in this so-called center of excellence, where you have basically built in an organizational knowledge, understanding, expertise that you can then apply to multiple new projects, to multiple new teams, etc. So that's this platform approach, giving you a common unified tool set. And in today's talk, I'm going to be discussing a few approaches, patterns for CI/CD pipelines in particular that will allow you to have more resilient software pipelines, essentially to build and test your software. and more. First one, probably the easiest one, is some kind of starter project templates. So if you go to IntelliJ, you create a new project, you select Gradle, Maven, whatever, it will generate you this kind of boilerplate. You will have, I think you'll even have a git ignore in there. But you won't have any like CI/CD configuration. What you could do, for example, is if you know what your CI provider is, if you know what tooling you're using, for example, let's say that we're using Sneak for our security scans throughout the organization. Who else I saw upstairs? Code Scene, for example, for code quality control. You can bake those tools into that configuration so that you can then create a template project straight in GitHub or whatever you're using for your repositories. So that when someone creates a new project, they already have everything configured. You have the versions pinned to whatever you want them to be. You have your build job already running. You have your test job already running. You have your security scan already running, checking your dependencies. You have your code quality. The Docker image is being built. You have everything pre-filled for quick deployment if it's, for example, a microservice that you're building. So very, very easy. Takes almost no time and immediately creates you much better, more resilient environment for building new software tools. And you're not even really touching the pipelines at all. You're just shipping some defaults. The second one is also pretty obvious. It's just using the API for something that's not maybe obvious or not possible straight in the dashboard. So if you think about your CI tool, you have a dashboard where you see like these are my builds, these are my jobs, these are my steps, these are the logs, all of these things. But that will get you, I don't know, 80% of the way if you stick to like Pareto principle. But for example, if you want to do some kind of advanced integration, some advanced orchestration, get some more data out of your pipelines that's not immediately visible on the dashboard, you will probably have to rely on the API. And I just want to say, like, check it out, like what you're missing from your tooling right now, whatever your tooling is, check if the API allows it. Maybe that's gonna solve some of your issues. I like an example where you basically can tweak the pipeline's behavior by passing parameters. So for like very wide-ranging jobs that have a bunch of different clients, coming back to a mobile example, for example, you can have various stores that you're targeting, various backends that you're targeting, and you want to just test against one of these combinations. For example, one of our test environments and this particular store, let's say Play Store or Huawei Store, whatever. You can configure that pipeline to run only the desired test if you parameterize things correctly. And that's only one API hit, and it's gonna save you a lot of time and also a lot of CPU cycles on your CI tool. Thinking about APIs in reverse, you get webhooks, or at least that's how I picture them in my head. Webhooks are pretty ubiquitous nowadays, and every single tool that you have probably has some kind of notion of webhooks, and they can even be used to trigger your pipelines. For example, not only VCS, okay, GitHub has someone's pushed a commit. That's a webhook trigger by default. It's just something that's baked into any CI/CD flow. but also observability tooling. Let's say you're rolling out a new release and Datadog tells you, pops up with an alert saying, hey, you have increased level of errors that you didn't have before in the previous release. That could trigger a webhook back into your pipeline to stop that rollout, maybe revert it if it's going on at the moment. And it can all be done in an automatic way. It also depends on whatever you're using. Container registry as well. Let's say you push a dependency, another team pushes a dependency to your Docker registry. And that dependencies, whichever projects depend on it, can then trigger a rebuild with that dependency in mind. So think about that. What could trigger your pipelines, and how you could essentially automate on top of what you already have. Or just webhooks that are coming from the pipeline. Maybe you want to collect statistical data, so you just want to know, like, my jobs have completed, my workflows have completed, analyze that in your data tool. Or you can set up custom alerts. For example, my production deployment job or like nightly tests have failed. Let's set up an alert in Twilio, page the right person, whatever. So that's another option. Building on the API story, you can also create an interface to whatever your teams are already using to communicate. For example, Slack. So think about who could be notified when in regards to your jobs, your deployments, your builds, failed, successful, any manner of scenarios. So maybe you want to notify your security team that you have a pending security review before you can release. Ping their team on Slack. You can connect that. Maybe you want to trigger builds based on what I just said, like the API pipeline parameters that you trigger to the API. Maybe you want to hook that with your chatbot. I know a team that basically allows QA people to essentially just request a build of this particular configuration through a chatbot, and then obviously that checks, have we done this build before? Yes, no. If no, trigger a build. If yes, okay, grab it from our cache, and again, saves them hours on a daily basis. So think about how you can weave that into your communication. The fourth pattern are environments that come and go, so ephemeral environments. Has anyone used Heroku in the last 5-ish years? Some of you have. So you know they have this thing which allows you to preview pull requests. So let's say you're building this this web page or this API. You can create this preview environments that essentially spin up whenever you open a pull request, and they live for the duration of that pull request, which allows you to easily review the changes on a live environment. And then as you merge it, it tears it down. Very, very useful. And you can do that yourself by just doing some orchestration. I'm sharing the slides afterwards, so these links just have some examples in there, and you can follow them along later. So we talked about that. There's also daily development environments that you might be interested in. So for example, if you have beefy machines in the cloud that you're keeping to during your kind of development day, you can tear them down, bring them up at the beginning of the day, hook them up to a cron job so that they are spun up whenever you actually need them. Or even spin up infrastructure for the purpose of a test. Like even Kubernetes clusters like DigitalOcean, Civo are really good for spinning up a whole Kubernetes cluster in like 5 minutes. So if you're thinking about like a long-running end-to-end test or close to end-to-end test that needs an environment, why not spin something up, tear it down, and you're still getting your tests in 10, 20 minutes total, which is acceptable for like an integration type test. Or for example, if you're spinning up very expensive hardware, like virtual hardware, for example, like NVIDIA GPUs, like they can be expensive and you don't want to run these things constantly. You can create your infra, provision it with, I hope you use infrastructure as code, Terraform, Pulumi, CloudFormation, whatever it is. Bring it up, tear it down, all in a pipeline. Very useful. I have a couple of examples in there. And there was a pretty excellent video from Victor Farcic about this exact topic. So next pattern I want to talk about is essentially triggering pipelines across projects. So if you think about pipeline, it doesn't need to exist in isolation. It can exist with other projects and communicate with one another, because obviously every one of them has some kind of API support. You can use that from the pipeline. It's just compute, it's just running bash commands. So why not do a curl call to a different pipeline, for example, if you want to offload some tests, if you want to notify a job that's kind of later in the downstream, you want to trigger that, you can do that too. I've done it for provisioning. I've done it for, like long-running tests, end-to-end test suite, which is kind of common across multiple projects. Triggered that once you have triggered a deployment. It's pretty powerful. And ultimately, all you need is a single curl call to your API. An extension of that I call circle back, pun intended, is when you want to get a pipeline talking back to the originating pipeline. So if you trigger it on one side, the other one then waits for it for the offloaded work to complete. Super useful if you have some common testing scenarios and you don't want to keep a job spinning and spinning and spinning. The way I did it with Circle, essentially I used this approval job, which essentially calls back as a manual approval step. Hey, this follow-up job has completed. Now you can go back and check its results and terminate based on whether it was successful or failed. So again, quite niche, but if you have a need for something like that, this is just something to think about. Now, we talked about development, testing quite a lot. Do you think CI/CD pipelines are only suitable for development? That was a YAML joke. No. Are you familiar with that joke? No? Okay, so Norway abbreviates to NO, and YAML 1.1 spec essentially took anything that closely resembles or vaguely resembles a negative value, including NO, International Code for Norway, to false. So anyway, pipelines beyond engineering. Of course, there are ways to get ahead with that. So not only can we build and test software, they're really good at that, but you could also help other business areas. For example, security. I talked about that already. For example, if you want to run a automated security scan, a whole report of your system, integrate that in your pipeline, it's going to save you a lot of time because you're going to be automating a ton of tasks that would otherwise have to be created, have to be managed manually. And wouldn't it be nice if you just gave your security team that you're relying on for their sign-off just the just the reports generated. Hey, this is what we're shipping. This is all waiting for you. Everything's been tested. Here's an environment you can play with. Prepare them everything as part of a CI/CD pipeline so that you're not blocked, they're not blocked, and they can focus on what they do best, which is obviously reviewing that everything is nice and secure and compliant. Batch processing, right? You're running compute, right? It can run nightly, it can run weekly. So whatever you can orchestrate, you can probably orchestrate that in a CI pipeline. Maybe it's more effective that way than using a dedicated tool. Maybe it's more cost effective. Maybe it's just easier to have a single configuration language for all of these tooling, and also a single team of experts that can go to your business analysts and help them set these up, backups, etc. A lot of use cases, and by having this kind of platform mentality, helping as many teams as possible with unified building blocks, you can achieve that. And lastly, I have to kind of go where everyone is talking about, which is obviously robots. And yeah, AI/ML, it's still a very, very emerging field. What means that what used to be the domain of data scientists who don't necessarily follow the software engineering approach, the method, and don't have the practices developed that we have built through decades of developing our craft and industry, is just lacking in this brand new field that's just exploding in popularity. So testing is hard, deployments are hard, just the way things are built and integrated is just not well done. But you can take your software engineering and DevOps expertise and bring that to a new team and kind of create these engineering practices before it's too late. Because you start shipping a bunch of ML modules, models, sorry, LLMs, whatever it is, you don't want that to be left without enough automation, because you want to be able to roll them back. You want to be able to test them continually and make sure that all of the releases, all of the deployments are done in a well documented and well scripted way. So include from training models. You can just get whatever GPU resources you need. You can train them. Again, CI/CD pipeline, it's just a scripted computer that spins up, tears down. You can do whatever with it. You can fine tune. Fine tuning is usually more popular nowadays just because you have a lot less requirement for a lot of CPU, for a lot of resources, because you take off-the-shelf models and retrain them, adapt them to your data set. You can continually test for behavior. You can test for hallucinations. You can test for correctness, for anything you want to avoid it kind of producing, and ultimately you can deploy new versions of this software with ease. Anyway, a couple of conclusions. So we talked about some common ways to solve new challenges, or maybe their existing challenges. Hopefully I have given you some ideas of what you can do with your CI/CD pipelines to help not only your team, but only teams adjacent to yours, or teams you haven't even considered that could benefit from these tools. From templating to just kind of spin up new projects easier, to integrations through APIs and webhooks to extend your pipeline reach, essentially, or orchestrating them so that you're testing however you want to test and reaching the teams you want to reach, for example, security, as I mentioned, and spinning up short-lived environments through infrastructure as code when you're applying tearing down. And that's about all I have for you today. As I said, the deck is here. I'm also going to upload it through the portal, so it's going to be all online, or you can just get it from this QR code. Anyway, happy to answer any questions or have a discussion afterwards. It's clear enough. But yeah, grab me afterwards if you want to chat.